So, good afternoon, everybody. So, my name is Guy Mordret. I will be the moderator of this panel for Ocean Space Contribution. So, I tell you, my name is Guy Mordret. I'm the CEO of a small company located in Brittany, in France, and I'm a former biologist before, and I set up a company specialized in scientific communication and software solution for pharmas, biotechs, cosmetic nutraceutics. And we develop also now solutions for big data sciences, and I think we will have an occasion to talk about this topic later on. So basically, we will talk about a very attractive topic, which concerns the collection of data, the treatment of data, which we call also big data somehow. And we will address the question of the new technology to treat those data, to represent this data. Let me introduce very fast our panelists. So we have Dr. Professor Anthony Emmett. He's a distinguished professor and director and vice chancellor emeritus of Scripps Institution of Oceanography, San Diego, University of California, San Diego. He is highly distinguished with more than 170 peer-reviewed publications. George Alexson Vieira is the CEO of Undersea, maybe another company. I saw you have another company, a startup company promoting a multi-sensor fusion system, including local sensors and satellite records. And your background is in mechanical engineering in Portugal. Claude Tremblay, you have a background in marine biology. You were a crew member on vessels of the Department of Fisheries Canada and Coast Guard. You have experiences as senior scientist of aquatic environments, and you are currently the executive director of the St. Lawrence Global Observatory since 2013. So I will ask Tony to introduce himself and talk about currently what project are you involved in, and you are involved in different projects like ocean robot, health industry, sustainability of fisheries. So let's introduce yourself, please.
Thank you, Guy, and thank you to the organizers, Pierre and Vero. I'm here today as one of the co-founders and co-owners of MrV Systems, which is an ocean robot company that is designed to sample the wealth of data in the ocean. So if we could have the first slide. Many of you, I think, will know the Argo program, which is a collection of 3,700 robots that profile the ocean every 10 days, descending to a depth of about 2 kilometers. The slide should show where they were last night, all 3,700 of them. So there are 3 or 4 companies that are making these robots. They're all sort of standard technology. And that was the core product of our company. The data they're measuring is the temperature and salinity, and that's one of the most profound consequences of global warming, the fact that we've dumped 250 zettajoules of energy into the ocean. So 93% of the heat from human global warming has gone into the ocean, and thank heavens it has, otherwise Sydney would be unbearable in the summer. So 2% has gone into the atmosphere, 2% into melting the ice, 2% into heating up the land mass. But there's much more data about the ocean.
No
do we have those 2 slides?
Because there was no slides for the panel.
Okay. So we're moving this business from specialized environmental floats into robots for everybody. So we will send you a robot that can be launched from a ship or from the air with a parachute. We'll sell you a robot that can lie on the ocean surface until some trigger is available, a whale passing by that you want to study something else in the ocean. And we'll let you load up this robot with a payload that you like. So we'll tell you how many kilograms we can give you, how many amp hours of energy we can give you, how many round trips we can make between the surface and the bottom of the ocean. And so our customers either come to us with new sensors they want to insert in the robots, or they want our help in developing new sensors, miniaturizing sensors. So basically any kind of physical or chemical measurement that you can make in the ocean, we'd like to be able to do robotically. Of course, we get the data back from the brief time we stay at the surface, comes back through the Iridium telephone network back to your lab. And I think the excitement, which we may get to talk about, is moving into the biological realm.
Yeah, because I need to give the talk to Claude. I will ask you to introduce yourself and to present shortly the GSLO project and about the importance of the integration of the data in your project.
Okay. Hello everyone, my name is Claude Tremblay from the St. Lawrence Global Observatory. Like Guy mentioned, I have a bachelor degree. In the last 20 years, I've worked in different fields, always on the ocean as a crew member on a research vessel, search and rescue vessel, also for the industry. And I've worked in aquaculture, toxicology, and fisheries protection for fisheries in Oceans Canada. So I have a large view of all the use that is being done on the St. Lawrence Observatory. To answer what the SLGO does, I'm just going to recall a few remarks that were said at the beginning of this conference that were said by the ministry in the remark session. So these issues that were brought up were the increasing need to observe in a fast-changing environment, the need to base decisions on strong science and understanding of the ecology for sustainable exploitation of the ocean, and the fact that water has no boundaries and we need to share knowledge. So 10 years ago, the St. Lawrence Global Observatory was created exactly to address some of these issues. So these issues have been there for a long time. So SLGO was created by a network of data producers, like a federal and provincial department doing science, university research center, and also NGO. SLGO does not own any instrument and we do not do the research. It's all our partners that do the research and they collect the data. Our job is to centralize the data or make them available through one website. So if scientists or decision makers are looking for data, they go on our website and they can visualize the data and have access to all the community data that is produced by everyone. So this is mostly our activity, and like any use, our work translates into social benefits to support decision making, for instance, BioMarine. In fact, yeah.
Thank you. So I invite you to visit the website of the OGSL, or GSLO in English.
Yeah.
Sorry.
The SLGO.
SLGO. George, I'll let you to introduce yourself and talk about your underwater vehicle you developed in your company.
First of all, thank you very much for inviting me for this session. My name is Jorge Vieira. I'm a co-founder of Undersea. Undersea is a startup company which is under the program is a Business Equation Center, which is a program for technology transfer from space to other applications. Under this program, we are developing a multi-sensor fusion system for water quality monitoring. So the first prototype will be a housing system, which can be attached to other underwater vehicles to get data regarding water quality in real time. We will be making also satellite readings about water quality at the surface, and we will combine all the data from local and satellite readings. This system will evolve into an AUV, the water vehicle, in another stage. But now we are focused on the sensors and how to collect data, how to combine all the data, and how to deliver this to the customer.
Okay, thank you. So we see that a lot of data could be collected from different instruments or from different origins. either from fisheries, for example, or from database provided by government, or for physical or chemical measurement, for example, or from captors. So a lot of data can be combined to be exploited, to be treated later on. And so now I will ask you, each of you, how the information is extracted, because you have the raw data from your instruments, your captors, and eventually cleaned, because some data need to be cleaned and annotated. So I know in biology, in marine biology, you need to annotate some data, and then integrated and represented. And Tony, can you say how the data you collected are extracted and represented for you?
Yes, so there's in the environmental side of our business, there's an international consortium, 23 countries, that get together and extract the data from these 3,700 robots. They're quality controlled in a uniform way, and then they're distributed around a couple of data centers from a master center that happens to be located at Scripps at the moment. It moves around the world. And everybody in the world, not just the 23 countries, but every scientist in the world can get hold of that data. The question is going to be from now, and that's, there's many interesting questions about that, because this data is connected both in the open ocean, outside national areas of national jurisdiction, and inside exclusive economic zones. And over the decades, we've had trouble with the occasional country that says you can't use our data inside our economic zone, and then it's a big negotiation. So we expect more of that in the future as people develop sensors to take dissolved oxygen and pH and chlorophyll and moving into more biological variables. People will start to realize that there's intrinsic value in this data. Even in the end towards bioprospecting, where you do it completely robotically. And so all those jurisdictional issues that should be covered by the United Nations Convention on the Law of the Sea, but are not currently covered. Our hope is that first the United States Senate will sometime get around to ratifying that convention, and then we can all sit down and make some small changes to that convention so we can agree how to treat these resources that really belong to all of us.
To all of us, yeah, thank you. And Claude, you mentioned integration of multidisciplinary data might generate some clutter or noises in your data, so you have to clean your data or apply some quality controls.
Yeah, well, when you integrate a large amount of data, multidisciplinary data coming from multiple partners, there is a challenge of visualizing these data to make sure that they speak and that there are no conflict between the interpretation you might make. Because if you have too many layers, the data don't speak. So you need to understand the user's needs to make sure that you disseminate the right thing in the right way, the visualization. Yes, so that's why at SLGO we have on our board we have we have a scientific advisory committee and a board, and on the board we have the data producers and also some representative of the industry, so that they can ask or communicate their needs regarding the data, the specific one they need and how they should be visualized. Because, for instance, for the navigation, there's a lot of information they need, and these information are detained by different organizations, and for them it's complicated to go get these data. So our job is to integrate them in.
So you need the intervention of some scientists or data scientists to just clean or interpret the results.
The data are being cured by our members. Exactly.
Yeah. George, how do you provide information or the information you collected to your final users?
Okay, it's a multi-sensor system, so we are collecting data from different sources, from satellites, from cameras, from sensors, optical and electrochemical sensors. All this data will be available in our website. It's a cloud-based platform where customers can access all the information. Some information is in real time, but we need to treat the data to combine, and then we will provide always on the platform thematic maps for each parameters. So up to, this is important, only up to 50 meters. Our system is prepared to submerge up to 50 meters.
50 meters down deep. Okay. So we can say that we talk about the amount of data collected for different instruments, or if we talk about robot or whatever previously. And so what is very important at the end, of course, you need quality control of the data. You need to clean the data and before to present, to represent the data for your target, which is maybe scientists, might be companies, might be a government also for economical reasons or societal reasons. So we talk about a very important item, which is the data visualization. Data visualization is able to provide a value proposition of the data collected and the data modelized and the data that are presented to the final user. So it's very important. And the new technology allowed us to do that kind of a representation. Now we will talk about what will be the next challenges for you. And Claude, you said that to follow to the data visualization, you talk about the 3D challenge as a challenge to the data visualization. It would be the next challenge for you for the observatory?
I think so, yeah. So at the St. Lawrence Observatory, since our job is to maximize the way that data are visualized, and the goal for that is to maximize data discovery. So if we take, for instance, acoustic data, it's a concept that's really complicated and hard for the common human to visualize. So I think in the future, by using 3D, it could be a way of visualize the acoustic data. For us, the challenge is not having access to the right technology. It's more having the HQP, finding the resources to really program and use the software that exists to do the job. This is the biggest challenge we have.
Right. Yeah. And Tony, the new challenge could be more as societal or business challenges for you, or business practice, licensing patents?
I think there's a challenge at the public good business area. So a lot of the data that the Argo network collects, is clearly valuable and has been used, by very non-traditional scientists. Sometimes at universities a long way from the ocean. One that springs to mind is, one of the predictions of global warming is there'll be more fresh water. The freshwater cycle will be increased because of the increased temperature of the air. There's more water that can be stored. So one of the scientists decided to check that with the Argo data by looking at the lens of fresh water that comes out of the big rivers like the Amazon and so on. So that's just a very clever idea from a young person using this enormous data set. And so clearly there's a global benefit, a commons benefit for that. But as we get forced into wanting more and more specialized data sets, we get more into the commercial realm where it's not so clear how, we tap into that great reservoir of talent in the whole world. And yet there's a shrinking number of countries that pay for the data. I think in terms of opportunity, I think, the militaries of the old Soviet Union and the United States collected a lot of data for 50 years and made it restricted access to it. I think there's a lot of data, polar ice caps is a story that's been told a couple of times where the old Soviet Union and the US agreed to release their ice thickness data. But it turns out there's a whole lot of acoustic data that various militaries connected that would tell us about the way in which noise pollution is growing in the ocean. So I think we still have a historical job to do to try and free up that 50 years worth of data and learn a lot from it.
I would just like to add that there's in fact a huge challenge. There's lots of data that's been piled in the past that is not available right now, and now we have new instrument that is collecting data at a huge, really big rate. So there's a lot store archive that we have to have access, and there's a lot. So this is a big data problem. It's another issue.
And a new challenge.
Yeah, I mean, raising money to curate data is probably the hardest thing.
Yeah, that's
exactly.
For
you can collect new data, but if you want to look after it, nobody wants to pay.
But I think the key is to stop piling them for sure.
Yeah.
The
Well,
new ones that are being collected, let's make sure they're available
to
as
make sure
fast
that we
as-
have the algorithm or the software to treat the
Yeah.
data, even the past data. Yeah. And George, your next challenge will be more a business model challenge?
Yes,
I
business
understood.
model, because we are not selling devices, we are selling data.
Data, yeah. Services.
It must be data informed, based on contextual information. So we think cloud computing is the perfect tool to analyze all the data and to trying to make available data regarding to decision making. So customers need to have the data in a way they can decide what to, because only data from different sources can turn into a big data issue, and
This is a big data issue.
and this is something
Are you
we
using
need to.
the data visualization or some
Yes, it's
representation of the, yeah?
The data comes from different sources, and we must be careful. We must to treat, analyze it, and deliver the data in a way customers can see what is happening.
Okay. Thank you. What we can see, or as a conclusion, we can say that the big data in science, or big data sciences, I don't know the terms, used in the literature, we have a new business model. There was some data available from the military, for example, from other university or from government. But there's still, now we can say there is a very new business model for this big data, and it will go to new expectation. And we talk about economical reasons also. We can call about data monetization, because companies or government may have the right to sell their data, and so monetize their data. So it's included that big data business model. And we saw that there is a lot of applications, well, there was some military application, but of course there was some sustainability application, economic perspectives, of course. We talked in the previous presentation about the stocks for fisheries. There is some also application or challenge for information of the general public, because the general public needs to be informed about what happened into the ocean. And of course for the scientists, because they need also to treat and they need to continue to collect the data and to treat and exploit this data. So we are at the end of this panel, and I wanted to thanks Tony Emmett, Claude Tremblay, and Georges Vieira, and thanks also BioMarine for inviting us to present this topic to BioMarine competition. Thank you.